Review question 6, factorize each of the following. All right, so for part A, I have 9x squared plus 6xy plus y squared. Okay, just taking a look at this, this is a special kind of a quadratic equation, or I can also see it as a special identity equation as well. So I have two methods of doing this. All right, first one is using multiplication frame, which is the box method. Okay, usually for box method, I would go with quadratic equations such as 9x squared plus 3x minus 7. For example, I have an x squared term, I have an x term, and a constant term. This is the most common kind of quadratic equation. Okay, but for this kind of equation whereby I have x squared, xy, and y squared, I can also do it by multiplication frame over here. All right, just to take note on the positioning, 9x squared will go in the middle, y squared will come over here, and I must make sure that these two boxes over here must add up to 6xy. All right, so let's start off with the y square first. Okay, the easier one. I only have one combination, and that would be y and y. Y times y can give me y squared. There's no other combination to this. As for the 9x squared, I have two combinations. One is x times 9x. The other one is 3x times 3x. Okay, so maybe I'll just go with 3x and 3x first. All right, so let's just do a check to see if we can add up to 6xy for both the yellow boxes. So for this first box over here, it's a multiplication of 3x and y, which gives me 3xy. And for the second box over here, it's a multiplication of 3x and y as well. So again, it gives me 3xy. All right, just to double check, 3xy plus 3xy, does it give me 6xy? Yes, it does. All right, so now that I'm done with my multiplication frame, I will just put it in terms of their brackets. 3x plus y for the first one over here. Second one, it's again a 3x plus y. So how can I combine and simplify this further? I can just write 3x plus y, bracket, square. Okay, so if I want to use my special identity to factorize this, I can too. It is using a plus b bracket square, which is a squared plus 2ab plus b squared. Meaning this is my, this 9x squared is my a squared. This is my 2ab. This is my b squared. All right. Common mistakes. A lot of students, they will think that my a is just my 9x. No. So if my a is 9x, when I expand it, it becomes 81x squared, which is wrong. Okay, you must always remember to square root your number as well. So in this case, a is my 3x, b is my y. All right, so if I were to plug it inside this formula over here, it gives me 3x plus y bracket square. It is actually the same answer. Okay, now let's move on to part B. I have a 27a square c minus 192b square c. So taking a look at these two terms, I will go with extracting of common factors first. Common number between 27 and 192 would be 27. No, they are multiples of 3. Let's go with 3 first. All right, so I'll pull out a 3. I'm left with 9a square c minus 64b square c. All right, and as for the algebra, I have a square here. I don't have an a term on the other side. I have a c here. I have a c here, meaning I'll be able to pull out a c from both. And I'm left with 9a squared minus 64b squared. Okay, is this a fully factorized version of this equation? No, because for the inner bracket, I still have my special identity, and I can use a squared minus b squared, which gives me a plus b, a minus b. So a lot of students, they would just stop here and they would not get the full entire marks for this question. All right, so for this portion, 3c, I'll just copy back. This is my a square. So a, again, I will have to square root my 9 and square root my 64 to get to my a and b. So that's a 3a minus 8b square. and I'll put it in a box. Okay, and from here, I can further factorize it. 3a squared minus 8b squared using that special identity gives me 3a plus 8b, 3a minus 8b. Just a quick scan. Is there anything else that I can do to factorize this equation? No, there isn't. So this is my factorized version of part B.